طيب بسم الله والحمد لله والصلاة والسلام على رسول الله وعلى آله وصحبه ومن والاه. Any questions before we proceed? طيب. This is what we did last time. We carried out or we showed that this sequence an equal minus 4 to the power n is actually a solution to this recurrence, right? To an equal minus 3an minus 1 plus 4an minus 2. Last time I said that we are going to do part D, but then to tell you the truth, when I looked at it, part D is not that hard. It's not that hard, you know. It's not that much harder than part C. Since we already did part C, خلاص, I'll leave it to you as an exercise. Okay. So inshallah, you can do part D, and I don't think it's a big deal. Okay. So let us move on. Let us move on to teach you some haram stuff. Okay. Formulate some haram stuff. Suppose that a person deposits $10,000 in a savings account at a bank, yielding 11% per year, with interest compounded annually. Now, let me first explain it. So basically, the idea is you take 10,000, you put them in the savings account. It stays in the savings account. Okay, you don't touch it. Now, every year, once a year elapses, they will give you 11% on whatever is there. Okay. طيب. The year after, they will give you 11% on whatever is in the account, or on the original amount. Whatever is in the account. Why? Because it says here compounded, right? Basically, the word is compounded. Compounded annually means whatever is in the account, they will just basically compute 11%. طيب. So now the question is, how much will be in the account after 30 years? So in order to solve this type of questions, we need to do two things. The first thing that we need to do is we need to compute or we need to formulate the money in the account. Okay. So let us do the following. Let me say so this is basically the solution. Let Pn denote the amount of money in the account after n years. Okay. Let it denote the amount of money in the account after n years. Right. So who can tell me the $10,000 will represent what? اللي هي ايش؟ P0, صح؟ P0. So basically we have P0 equal 10,000. طيب. Now, let me ask you this. Is it easier to represent Pn as, a function of n, or is it easier to represent Pn as a function of the previous value, which is basically n minus 1 or n minus? It's the previous value, صح? So basically, Pn will be equal to what in this case? Pn minus 1, أيوة, times 1.11. Basically, what you're saying is it's Pn minus 1, which is the original or the amount that was saved in year n minus 1, plus 0.11 of what is in that year, صح? Which is, if we add, we get 1.11 Pn minus 1. We get 1. This is basically the recurrence. This is what we call the recurrence equation or the recurrence relation, right? So now we found the recurrence relation, we found the recurrence, and we found the initial value. Now we need to solve it. Now, how do we solve it? Well, usually we use a method which is basically called the expansion method, recurrence expansion method. I think your book maybe calls it the iterative method, which is basically, you try to come up with the closed form solution by successively substituting Pn minus 1, Pn minus 2, and so on and so forth, right? So let's do what it says, okay? So basically Pn is 1.11 Pn minus 1, صح? Right, so what I will do is, I will say, okay, so Pn is equal to 1.11 Pn minus 1, which is equal to 1.11, and then I will put brackets. Now, what am I going to do with the brackets? I'm going to take the Pn minus 1, and I'm going to put it here. So if I put here Pn minus 1, what will be the result? 1.11 Pn minus 2, صح ولا لا? So 1.11 Pn minus 2. And notice that I put it in brackets, right? Notice that I put it in brackets. Now, why would I do that? Well, let's just divert a little bit. Assume that the thing was, like, for example, Pn, it was, let's say, 5 Pn minus 1 plus 3. Okay, let's use much better. Okay, Pn minus 1, Pn equal 5 Pn minus 1 plus 3. Now, if I want to expand Pn minus 1, the best thing to do is to say 5, and then I'm going to put Pn minus 1 here, then plus 3. Okay. Now, what am I going to put between the parentheses? لا. هنا Pn minus 5 Pn minus 1 صح؟ if I put here n minus 1 ايش راح يكون عندي؟ Exactly 5 Pn minus 2 plus 3. Okay, plus 3, and then I have that plus 3. Okay, this way, if you do that, you will not make a mistake. If you try to do it without, putting the parentheses and substituting, by the way, there is a big possibility, you will make a mistake. Okay, so that's why I put the parentheses. واضح? Fine. Okay, so let's move on. So now, who can tell me now what is the Pn? 1.11 to the power 2 Pn minus 2. Now, do you see a pattern? You see a pattern. Now, my suggestion is, although here the pattern is actually very simple and it's very easy, but my suggestion, just to be on the safe side, do the expansion one more time. Okay, just to be on the safe side, do the expansion one more time. So let's do it one more time. So basically we have, this is equal to 1.11 square, and then Pn minus 2. So what is Pn minus 2? 1.11 Pn minus 3, صح? So therefore Pn صارت ايش؟ 1.11 cube, right? Pn minus 3. So now, if I want to write it in terms of J, Pn is equal to 1.11 to the power J. أيوة. ممتاز. Pn minus J. طيب, when am I going to stop? When am I going to stop? When J is, when n minus J is equal to what? Huh? So we will stop. We will stop when n minus j equals 0, which means that j is equal to what? When j is equal to n, صح? So now all what I need to do is I just need to substitute. Whenever I see j, I substitute ايش? I substitute with n. So basically Pn is equal to 1.11 to the power n times T0 اللي هي ايش؟ اللي هي 10,000, right? So this is basically equal to 10,000 multiplied by 1.11 to the power n. So now if I want the amount after 30 years, what do I do? P30 equal 10,000 multiplied by 1.11 to the power 30. Okay. Yes.
Why say that n minus j equals 0?
Who can answer him? Why did we say that n minus j should be equal to 0? Huh? Because we will keep expanding. We will keep going from Pn to Pn minus 1, Pn minus 2, Pn minus 3, until we reach what? Until I want to reach the initial condition. ايش هو the initial condition? It's P0. So I need to do this until n minus j equals 0, which happens when j is equal to n. واضح؟ تمام. Okay? طيب. Sequence generalization. So one of the interesting problems is basically if I give you a few terms of a sequence and I ask you, well, what is a formula or a rule by which you can generate the next terms of the sequence, right? So what we will do is we will give you now first few examples, and then I'll try to give you some hints on what can help, in coming up with the pattern or the rule or the formula in a a reasonable amount of time. So let's start with the first sequence. Anybody can tell me what if I want to write it in terms of an? What will be an in this case? Yes. It's 1 over 2 to the power n. Oh, n starts from 0, 1, 2, right? طيب حلو. Second one يا شباب. 2n plus 1. So an equal 2n plus 1. Will n starts from command 0. Now, do you notice this is what form of a sequence is this? It's the odd numbers, صح? No, what I meant was we took two type of progressions, arithmetic or geometric. Is this arithmetic or geometric? How do you know an arithmetic from a geometric? At least you know arithmetic. It difference is constant, صح? The difference between any two consecutive terms, is constant. So here the difference is ايش? Is 2, right? So all what you need to do is just say, an is equal to 2n, and then plus the first term, and we assume that n starts from 0. طيب, if we assume that n starts from 1, do you know what is an? n minus 1. In that case, it is 2n. It is 2. That's why, in proofs, when I ask you to prove this about this as an odd number, you can either use both. You can use either definition, whether it is 2n minus 1 or 2n plus 1. It doesn't matter. Okay. Now. an equal لحظة شوي. an equal n plus 2. طيب let's an equal n plus 2 صح؟ طيب when n is equal to 1 ايش راح يعطيك؟ لو when n is equal to 2 doesn't work صح؟ طيب okay next one minus 1 to the power n when n starts from 0. Okay. Next. ايش رايكم؟ طيب if you cannot come up with a formula, can anybody come up with a rule? Go ahead. The number n repeated n. So basically the rule says this is the number n repeated n times before incrementing it and then incrementing it by 1. The number n repeated n times. طيب وبعدين incremented by 1 and same process repeats. I wrote it in 3 different ways in the 3 different sections. Okay, and it seems to me that maybe I wrote it nicely the first time. Maybe I will see which one is nicer, and I will put it here. Okay, and I will put it here. So basically, who can tell me, for example, the next 10 terms? What are the next 10 terms in this case? Well, you have 5 times, and then you'll have 6 times. So 6 4 times. If I 6 5 times. If I want the next 10 terms. If I want the next 10 terms. طيب next. كتابة هلا I remember in a few years ago I mentioned that it's very hard maybe to come up with a rule with a formula, and one of the students, mashallah, he was an excellent very bright student. Within 3-4 minutes he gave me a formula. If you come up and I forgot it, to tell you the truth, I forgot it. If you are up to the challenge, please come up with your formulas and share them with us in the discussion board. لا أنا بدي formula. بدي an equal some formula, some function. Write it in terms of a function of n, a closed form, a closed formula. Yeah, 0 to infinity, yeah, 1 to infinity, doesn't matter. No. You can use the floor, ceiling, you can use whatever function you want. شو رايكم؟ Okay. طيب. Last one is easy. Yes. Excellent. So an equal 6n plus 5 n starts from 0. Okay, because again it is an arithmetic progression, right? It's an arithmetic. Right. So in real life, if you see such a sequence, what should you do? Well, the best thing is either you write it in front of you, you write some sequences like n square, n cube, 2 to the power n, 3 to the power n, 4 to the power n, n factorial, right? Either you do this, or you can run, these sequences. You can, look at few terms of these sequences while you are looking at the sequence at hand, right? And then you will notice that sometimes it really helps. So, for example, let's look at this one. Now, here it says, assuming that your formulas determine the next 3 terms. Well, it's up to you. I'll leave it for you to determine the next 3 terms. Let's just try to find out what is my sequence. Look at the first one and tell me which one is it closer to from whatever is mentioned here at the top. N to the power 3. So what is the formula for n to the power 3? ايش رايك؟ 3 to the power n. طيب, so 3 to the power n. What do you want to do with 3 to the power n? an equal 3 to the power n minus 2, and n starts from 1. Let's check it out. Look at this. If you look at 3 to the power n, you see that we have 3, 9, 27, 1, 7, 25, 81, 243, 729, 2187, 6561, and so on and so forth. Do you see that it is actually the closest? So it's actually a good idea to do that. Okay, it is a good idea. It is a good idea to do that. Right. Okay. So next one, part B. شو رايكم? An easy one. 4n plus 7, and n starts from 0, صح? طيب, the last one. Yes. Say that again. It's binary number. It's binary number representation, ولا لا? So basically, an is equal to n in binary representation. بدك زيادة؟ شو بدك زيادة؟ Yes, yes. I mean, unless I really told you to come up with a formula, and I don't know if there is a formula that can give me this, but as a rule, this is okay. Okay. طيب يا شباب, any question? Okay. Let's move on. Now let's go to summations. Now in summations, we are going to represent the summation in one of these 3 forms. Now, of course, here you see 2 forms repeated, but inshallah, I will fix this. The j equal m actually should appear here. Okay, j equal m to n, right? But inshallah, I will fix it. So what does it represent when I say, sigma aj from j equal m to n, or sigma aj, and here I will say j greater or equal to m, less than or equal to n. So basically what this means is I'm going to run the formula here, aj, starting from the least value of j, which is in this case m. M, by the way, is called the lower limit. And I will increase the value of j by 1. Every time I increase the value of j by 1. So this will be am plus 1 plus am plus 2 plus am plus 3. And this will continue until I reach plus an. So an is basically the upper limit. An is the upper limit. And we call j the index of summation. Can we use any other variable like k مثلا or I? You can use whatever variable, right? You can use whatever variable. طيب. So now with these summations, the question that arises, and inshallah we will do the practice day after tomorrow, is, well, how do I compute the summation? How do I find the value of a summation, right? Now, the following rule will actually help us. What does the rule say? The rule says the following, that the summation from j equal m to n of axj plus byj, and here take note that a and b are constant. Basically, j does not appear inside a and b. J, the index j, does not appear inside a and b. The summation is equal to, isn't this equal to the summation of axj from j equal to m to n plus the summation of byj from j equal m to n? Why? It's commutative, صح? I can rearrange or I can reorder, these terms such that, ax1 plus or axm plus axm plus 1 plus axm plus 2 will come all before bym plus 1 and so on and so forth. So I can split them into two. Not only that, but I can take the constant, I can take it out. Okay, I can take it out. Like, for example, sigma a from j equal 1 to 4 is what? Sigma a from j equal 1 to 4. This is what? A plus A plus A plus A, صح؟ اللي هو ايش؟ هو 4A، مضبوط ولا لا؟ Which is the same as A sigma 1 from j equal 1 to 4. What is sigma 1 from j equal 1 to 4? 4. Sigma 1 from j equal 1 to 4 is equal to 4, so it is basically A times that. Make sure you understand this rule and you apply it properly. Okay? Say that again. Yeah, because this is addition. Addition is commutative, مش السيجما. ايه طيب يلا يا شباب. First one. Express the sum of the first 100 terms of the sequence an, where an is equal to 1 over n for n equal 1, 2, 3 up to اللي هي ال 100 as a summation. What should I write? Sigma of ايش؟ j equal 1 up to 100 of 1 over j, مش 1 over n. 1 over j, right? So this is the sum of the first 100 terms. طيب. Next, what is the value of the sum sigma 2j square from j equal 1 to 3? Okay. Now, what is the first thing that should come to your mind when you try to find the summation? Take which ايش هو الconstant? 2, صح? Take it 2 outside. So from j equal 1 to 3, this is equal to sigma 2 sigma j square from j equal 1 to 3. طيب. Next. ايش 3 minus 1 plus 1؟ شوف هنا طلع. This is sigma j square. So this is 1 square plus 2 square plus 3 squared. So this is 2 times 1 plus 4 is 5 plus 9 is 14. Huh? So this is equal to 28. Okay, this is equal to 28. طيب, notice here that we were able to do this summation because the summation terms are the number of terms is small, صح? From j equal 1 to 3, right? Similarly here, for example, what is the value of the sum sigma minus 1 to the power j from 2 to 7, from j equal 2 to 7? Well, this will be equal to 0. ليش? Well, this is minus 1 square plus minus 1 cube plus minus 1 to the power 4 plus minus 1 to the power 5 plus minus 1 to the power 6 plus minus 1 to the power 7, right? طيب, minus 1 square is what? 1. Well, minus 1 cube. So if the previous term is 1, the next term is minus 1. If the previous term is minus 1, the next term is 1, صح? So this is basically 1 minus 1 plus 1 minus 1 plus 1 minus 1, which is equal to 0. How many terms do I have here? I have 6 terms, huh? From 2 to 7, I have 6 terms. So 6 terms, 3 terms, I mean, this is manageable, right? But what if instead of sigma j, sigma from j equal 1 to 3, it was sigma j equal 1 to 100, or 200, or 500? Well, good luck, putting everything. See, that's why we need to learn about these formulas. Okay, so in this case, by the way, I really highly encourage you to memorize the first 4 summations. Okay, I'm pretty sure down the road you're going to use them, and you will use them a lot, right? If you are worried about exams or quizzes, these will be provided to you. Okay, these will be provided to you. However, if you memorize them and you solve questions on them, most probably you will become very quick in answering these questions. And speed is very important in exams. Okay, speed is very important in exams. Right. So, for example, this one, inshallah, we will prove it today. Sigma a r to the power k from k equals 0 to n is a r to the power n plus 1 minus a over r minus 1. In fact, I'm not sure why your author or the author of our textbook insists on putting the a. Then the a I can take it outside, huh? The a I can take it outside. أنا, for example, and I memorize sigma, r to the power k from k equals 0 to n is basically r to the power n plus 1 minus 1 over r minus 1. I don't know why did he add a, but anyways, we'll add it. What is sigma I from I equal 1 to n? N times n plus 1 divided by 2. طيب, what is sigma I square from I equal 1 to n? N times n plus 1 times 2n plus 1 divided by 6. طيب, what is sigma I cube from I equal 1 to n? By the way, it is sigma I all squared. It's sigma I all squared. This is the easiest way to memorize it. Okay, this is the easiest way to memorize. And then we have a summation of x to the power k from k equals 0 to infinity, kx to the power k minus 1 from k equal 1 to infinity, which is 1 over 1 minus x squared. We'll talk about them later. Right. So before we go to the proof of the first one, which is really a very nice proof, let me just talk about index change. Sometimes we will need to do index changes. Okay, and let me give you an example. Let's assume that you have sigma 4i square from I equal 100 to 1000. Do I have a formula for this? I have from 0 or from 1, huh? I have from 1. I don't have from 100. I don't have from 100. So one way to solve this type of questions is to basically change the index. Instead of dealing with an index from 100 to 1000, basically I want to deal with an index from 1 to, now here, how many? 900. 900 صح? 900. So it will be from 1 to 900 صح? From 1 to 900. How can I do that? Well, this is what we will learn. Okay. So what we will do is we will come up with another variable, and we will let that variable go from whatever I want. Okay. So for example, let's assume I have sigma j square from j equal 1 to n. I want my index, instead of starting from 1 to n, to go from 0 to n minus 1. I want my index to go from 0 to n minus 1. How can I do that? Well, what's the if I want to introduce k that will go from 0 to n minus 1, what is the relationship between k and j? Exactly. So in this case, k is equal to j minus 1. See, when j is equal to 1, k is equal to ايش? 0. When j is equal to 2, then k is equal to 1, صح? When j is equal to n, k is equal to n minus 1. طيب, now you wrote k equal j minus 1. Now what you need to do is you need to write j in terms of k. So this is equivalent to saying j is equal to what? K plus 1. So basically sigma j square from j equal 1 to n is equal to sigma. Now, instead of j, I'm going to use k plus 1 whole square, and from k equal ايش to ايش? From k equal 0 to n minus 1. Okay, from k equal 0 to n minus 1. واضح يا شباب؟ Yeah, لانه ال k equal j minus 1. If you don't change ال n, ترى راح يكون في عندك هنا more terms, صح؟ او less terms, right? Okay, and then you can continue. Then you can continue. طيب. Okay. So now the last thing that we will do today, inshallah, is to prove this this formula. This is, by the way, the reason why I really like you to see this, because in fact the proof is very beautiful. Okay, I know you hate proofs, but I hope that you will like this one. So let's do the following. Let's write, because this is what I want. I want to find a formula for S, which is equal to sigma a r to the power j from j equals 0 to n, صح? From j equals 0 to n. طيب. So what I will do is the following. Let me rewrite. Let me first multiply by r. شو رأيكم? Does it change anything if I multiply both sides by r? No. So r times s is equal to, if I multiply r by this summation, what would it become? J equals 0 to n of a r to the power j plus 1. a r to the power j plus 1. طيب. Now, let me look at the terms of this summation. Okay, let me look at the terms of the summation. What are the terms of the summation? What is the first term? A r, صح? When j is equal to 0, it's a r to the power 1. a r plus ايش؟ plus a r squared, صح? plus a r cube. All the way a r to the power n plus a r to the power n plus 1. a r to the power n plus a r to the power n plus 1. طيب بالله, this one is what? Is a, صح? plus a r plus a r squared all the way a r to the power n. طيب, in order to get this summation, what do I miss and what do I need to add here? I need to have an A, صح? I have something additional اللي هو ايش؟ اللي هو ال AR to the power n plus 1. طيب, if I want to add an A, I should subtract an A, صح? So this is equal to what? This is equal to A plus AR plus AR squared plus AR to the power n plus AR to the power n plus 1. And then don't forget to subtract the A. Don't forget to subtract the A. So now you have this is equal to RS, صح? طيب. And what about the first, these terms? What is this, by the way? مش هذا هو نفسه S? So I can say that this is equal to S plus AR to the power n plus 1 minus A. صح ولا لا؟ شو رايكم اسوي؟ I think now the trick has become clear. Take S to the other side, صح? Take S to the other side. So RS minus S equal to what? AR to the n plus 1 minus A, صح؟ طيب وبعدين R minus 1 multiplied by S is equal to AR to the n plus 1 minus A. So now S ايش بيساوي؟ AR to the power n plus 1 minus A divided by, شو رايكم بهالبروف؟ Very nice, huh? It's like I don't know. You know, we took the summation, we just multiplied by R, and we noticed that the whole summation is actually inside, but it was missing just A, or there was some additional thing. So we just removed A, subtracted and added A. I got my summation S. I just brought it to the other side, and now I have a formula for it. And now I have a formula for it. Okay, Shabab? Any question? Any question on the proof? Say that again. Yeah, ايش رايك؟ Oh, thank you for reminding me. This formula is if R is not equal to 1. شايفين في هنا أنا I'm dividing by R minus 1, صح؟ I'm assuming that R is not equal to 1. طيب, what if R is equal to 1? طلع هنا. Sigma AR to the power J from J equals 0 to N. R to the power 1 is equal to what? Not R to the power 1. 1 to the power J. 1 to the power J is equal to what? 1 to the power J. 1 to the power J. 1 to the power J. 1. 1 to the power J is equal to 1. I can remove ال 1 to the power J, صح؟ شو بضل عندي؟ sigma A from 0 to N, مظبوط؟ طيب sigma A from 0 to N مش بقدر اطلع ال A برا؟ صارت A sigma 1 from 0 to n. طيب sigma from 0 sigma 1 from 0 to n كم بيساوي؟ n plus 1 لانه من 0 مش من 1. لو بادي من 1 it is n plus 1. لكن since I'm starting from 0 it is n minus 0 plus 1 it is n plus 1. So that's why it is n plus 1 multiplied by but thank you for pointing this out. Okay, I didn't prove it لانه it's easy صح. The second one is easy. Okay شباب. طيب so let me stop here and let me stop the recording. Okay.